Okay, so for this example, it's basically saying that a mass of 2 kilograms goes up a 30-degree inclined plane, and at point A has a velocity of 2 meters per second. The mass goes up and returns to point A with a velocity of 1.1 meters per second. So what are the important parts of this question? We have to know that the mass is, and it's asking us, for this part A, find the work done by the friction force, right? Yeah, up to the plane, right? So the friction force. So what's the important stuff we have to know? We have to know that mass is 2 kilograms, the velocity A is 2 meters per second, and velocity, I'm calling it velocity B, but it's really the return of going back to point A is going to be 1.1 meters per second, but we can treat it like our V2 almost. Okay, so to find the friction force, we know that to find the work done by the friction force, first we have to know that the work net is equal to the change of kinetic energy, right? And what's the net? What are we netting is the weight force plus the friction force, which is equal to the change in kinetic energy. Now, solving for friction force, it's gonna equal the change in kinetic energy minus the work done by the weight force. Now, just plugging that in, it's also important to know that the work done by the by the weight force is actually going to be it's going to be 0, right? And so now we're just left with the change in kinetic energy, right? And you can see here, this is a 2 half times the mass, which is a 2, plus v times v2, which is 1.1, and then you subtract it by half times the mass times v2, which is 2, right? And then you solve it all out, and you should get negative 3.79 joules. And it makes sense that it's negative because the friction force always goes the opposite way of the displacement. Okay, now for part B, we're told that what is the velocity? Sorry, what is the distance that is when it goes up? What is the distance that the mass can keep traveling up the plane until the velocity is 0, right? How much is that distance, right? So okay, to find that, we know this mu of the velocity is 0.3. So to find that, we know that the change in kinetic energy is gonna be equal to 0 at the top, right? It's going up at the top. It's gonna end at 0, and then the initial velocity, we have the half mass times velocity squared to the initial. Then we know that the change in kinetic energy is going to be equal to the net work. So we have two work forces that we're working with. It's going to be the weight force and the friction force. But we'll to figure that out, first we'll be having to find what that equals to, and we're going to be using the change in kinetic energy first, right? So negative half times 2 to the power of 2 is going to equal negative 4, right? And we're really just using this part here, right? And that's going to be equal to negative 4. So we know that this is then equal to negative 4. But we need the work, to find the distance and displacement, right? Okay, so this can be this is the same as this. This is the work done by the weight force, and this is the work done by the friction force. And we know that the normal force is going to be 0, so all this part is going to be 0, right? And from here, we start working with this part, right? And this, now we start expanding this to sine of 30 with a displacement of s, right? And then we use cosine here, the 0.3 times the gravity cosine of theta to the displacement of s, right? So, and from here we're going to put everything as positive. If we put everything as positive, it'll help us solve for the sign of for the change in displacement. So once you put everything as positive, you just solve for, you factor out the displacement, the change in displacement, and once you factor it out, you divide everything to the other side, and then you get this here, right there. And then once you plug in all the numbers, you should get around 0.3 meters, right? So that's about it. That's it for that example.